Hi everyone, welcome back. Today we're going to look at section 2.3, which is Venn diagrams and set operations. So Venn diagrams are useful when you want to illustrate set relationships, especially when they get a little complex. They were developed by John Venn, and he used them to illustrate symbol logic in his texts. Basically, you'll see these a lot in probability when we get to that chapter. They're very helpful when you have two events that can happen at the same time. The rectangle represents the universal set. So this would be all of the numbers in the universal set. And then we would have our subsets here. So each of the circles are subsets of the universal set. When you have two different events, there's 4 different possible cases. This top one here is a disjoint event. So disjoint is also meaning mutually exclusive. And it means that they can't happen at the same time. So an example of that could be if you're dealing with probability and you look at the probability someone passes and the probability that they fail the same class. Well, it's impossible to do both, right? You're either passing or you're failing. So passing and failing would be mutually exclusive or disjoint events. There would be no intersection. In illustration B, that would be an example of a Venn diagram that shows subsets. So A would be a subset of B. In illustration C, we have equal sets. And remember that equal sets are two sets that have the same members or elements. So that's why those two sets are, the two circles are exactly the same. They're identical. It's one big circle. And in illustration D, we've got overlapping sets. And we're going to talk about what this overlap here in the middle represents in just a little bit. Any element belonging to the universal set, but not set A or set B, is placed in region 4. So set A or set B includes both of these circles. And anything that is not belonging to both of those would be placed in region 4. So basically, it would be anything out here in the rectangle that's not part of the circle. And we would place that down there where region 4 is. And we'll look at that a little bit more. Just like with numbers and expressions, there are operations, right? Like adding, subtracting, multiplying, dividing. Sets also have operations. One of the important operations of a set is called a complement. And a complement is just basically not. So think of it like this. If I was to take a set, so my universal set here is A, B, C, D, E, F, G. And set A is A, C, and E. If I want a complement, that would just be all of the elements that are not in set A that are part of the universal set. We symbolize set A. In your text, they use an apostrophe, so that represents a complement. And again, that would be not A. I've also seen them use a capital C as an exponent or superscript. And then less commonly, I've seen them use the tilde next to the letter as well. So just be aware that these are all ways they could symbolize complements. So in our example, as I said, we have the universal set A, B, C, D, E, F, G. And from the universal set, we're taking set A, which is A, C, and E. So we want to determine A complement and then also illustrate the relationship among those three sets, U, A, and A complement. So if A is the letters A, C, and E, if I want to find A complement, it's just all of the letters not including A, C, and E. So if I go to my universal set, I don't want to use A, C, or E. So my A complement would just be B, D, F, and G. And if I was to illustrate this somehow, here's my universal set, and here's my set A. Set A has A, C, and E. And my universal set would include A, C, and E, but also the elements that are not part of A. So A complement, which would go out here. That would be B, D, F, and G. So this represents A prime. So your A primes are out here. That's A complement. And set A is here, which is a subset of the universal set. There's two important operations we're going to look at in addition to complements. One of them is the intersection of sets A and B. So that's the set that contains all elements that are common to both set A and B, and they're going to be right here in the middle. So that includes the intersection in region 2. For the intersection, we use the symbol, it's an upside down U, so that would be A intersects B. You could also read that as A and B. So ends are intersections. So an example of an intersection is, let's say we have our universal set as the natural numbers from 1 to 10 inclusive. So that means 1 through 10, including 1 and including 10. So from our universal set, we've got our set A, B, and then C, which is the empty set. So the first thing we're going to determine is A intersects B. So what elements are included in both A and B? What are common to both? So if I look at set A is 1, 2, 3, and 8. And set B is 1, 3, 6, 7, and 8. So I want to know what's in common to both. They both have a 1, they both have a 3, and they both have an 8. So therefore, A intersects B would be the set 1, 3, and 8. In the next example, it says A intersects C. So in set A, we've got 1, 2, 3, and 8. And set C is my empty or null set. So if you'll recall, the null set is a subset of every set. So included in set A is the empty set. So they both have the empty set in common. So A intersects C would be the empty set, which remember you can either use two braces with nothing inside, or you can put a 0 with a slash through it. The next example says A prime, so A complement and B. So not A and B. Okay, so A I've written out a couple times. So what would not A be? It would be all the numbers in the universal set that are not A. So A is 1, 2, 3, and 8. So A complement would be all the numbers except that, up to 10. So 4, 5, 6, 7, 9, and 10. And then B is 1, 3, 6, 7, and 8. So now I'm looking for A, complement, and B. So what do they have in common? They have a 6 and a 7 in common. So A complement and B is the set 6 and 7. This next one says A and B, that quantity, the complement of it. So the complement of A and B. Okay, so one way we could do that is we can look at the first example we did and find the complement of it. So originally I found that A and B, if you'll recall from the first example, is 1, 3, and 8. So if I was to take the complement of A and B, it would be all the numbers except 1, 3, and 8. So it would be 2, 4, 5, 6, 7, 9, and 10. Now we have what's called the union of set A and set B. So that's the set containing all the elements that are members of set A or of set B or of both sets. The symbol for union looks like a U and it's an OR. So this is pronounced A or B. You can also refer to it as A union B. And remember that OR means union, just like AND means intersection, and complement means not. So when we're dealing with OR, we're looking at both circles together. So we're going to use the Venn diagram now to determine the following sets. Okay, so the first thing it's asking me for is the universal set. So remember, the universal set is every collection of elements in that rectangle. So the universal set here would be 3, triangle, square, circle, 9, 7, percent, question mark, pound sign, or hashtag 8. Now I want the just set A. Okay, so set A means I want all of this circle here. So set A is going to include the square and the circle in the middle because it's part of A. So this is going to be 3, triangle, square, and circle. Now I want not B. So not B means everything except what's in B. Okay, well, what do I have in B? B would be the square, the circle, the 9, the question mark, the percent, and the 7. So anything not in B would be the 8, the hashtag, the 3, and the triangle. Now I'm looking for A and B. So remember, A and B, and is intersection. So that would be region 2. It would be the square and the circle. Next, I want A or B. So that's one or the other. So A is here. B is here. So A or B would include all of the elements except the 8 and the hashtag. So that's going to include the 3, triangle, square, O, 9, question mark, percent, and 7. Next, I've got the complement of A or B. Well, right now I have A or B highlighted. So the complement is, remember, not A or B. So that would just be the 8 and the hashtag. And then if you'll recall, the last example is asking us for the cardinality or the number of elements in A or B. So how many elements are in A or B? If you count them, so here's A or B right here. If I count how many elements there are, there's 1, 2, 3, 4, 5, 6, 7, 8. Here's some more examples, but this time I'm going to include the unions and the intersections. So we have our universal set, which is the letters A through G, and then we've got sets A, B, and C. And in the first one, we need to determine A or B and A or C. So the first thing I'm going to do is write out what's A or B. So or, remember, is the union, right? You have to include all elements of A and also elements of B to make one whole big set. So if I was to figure out A or B first, if I look at A, I've got A, B, E, and G. And then if I look at B, I have A, C, D, and E. So I need to have one of everything. So I need to have an A, I need to have a B, I need to have a C, I need to have a D, an E, a G, and that would be A or B. This next quantity asks me to find A or C. So I'm going to do the same thing, except now I'm going to look at A and C. So I definitely need to have an A, and I definitely need to have a B, and I need to have an E, and a G, and an F. From that, I need to find the intersection, right? So where do they intersect? So let's see. We've got an A, a B, an E, and a G. So the final answer would be A, B, E, and G. Okay, in the next example, I'm asked to find A or B and the complement of C. So we already found A or B. I'm just going to recopy from the above example. C complement would be all of the elements that are not in C. So C is B, E, and F. So I'm not going to include B, E, and F. I'm going to go to the universal set and just use the other letters. So A, C, D, and G. And now I'm trying to find, again, their intersection. So the intersection of these two sets would be A, C, D, and G. Now we're going to look at what's the relationship between the cardinality of A or B, of A, of B, and of A and B. So given the Venn diagram to the right, how many elements are in A or B? Remember, you can pause the video and write down an answer and then unpause when you're ready. So if I'm looking at A or B, remember I'm looking at A or B. So if I count up how many letters there are, there's 6, 7, 8. There's 8 letters in A, and there's 3 letters in B. So 8 plus 3, there's 11 elements in A or B. One way to figure that out is to use what's called the general addition rule. In probability, that's what we refer to this as. So when we get to the probability chapter later in the semester, we will see this rule again. And this is where Venn diagrams are very useful. So this is saying if I want to find the cardinality or the number of elements in A or B, all I'm going to do is take the number of elements in A plus the number of elements in B and subtract the number of elements in A and B. Okay, so let's look at that. When I'm looking at just the number of elements in A, I only want this part here. So if I count, that's going to be 6 plus 2. There's 8 elements there. If I want the number of elements in B, I'm going to look at the whole circle B. And if you count, there's 5 elements there. But if you realize, though, when we took the elements in A and B, we counted some of them twice. And the ones we counted twice were the G and the H and the intersection. So we're going to take away 2. If you add 8 plus 5, you get 13 minus 2 gives you the 11, which is the same answer we got when we counted those elements together. So how can we use this rule? The results of a survey of customers in a McDonald's restaurant showed that 28 purchased either a hamburger or French fries, 20 purchased French fries, and 17 purchased both a hamburger and French fries. How many customers purchased only a hamburger? So what I'm going to do is I'm going to let H equal hamburger, and I'm going to let F equal French fries, and I'm going to use the general addition rule to figure this out. So I've got the number of people that ate hamburgers or French fries. That's just going to equal the number of people who ate just a hamburger plus the number of people who ate French fries. And I'm going to take away the ones who ate both. So hamburger and French fries. If I go through the problem, it tells me that 28 purchased either a hamburger or French fries. So N of hamburgers or French fries is 28. 20 purchased French fries, so I know that I'm going to have 20 for the number of people that purchased French fries. And it says 17 purchased both hamburgers and French fries. So I need to subtract the 17 away from the people who ate French fries or the people who ate hamburgers. Otherwise, I would count them twice. And I'm looking for N of H. So using a little algebra, I'm going to solve this for the number of people who ordered just a hamburger. So I've got N of H plus 3, if I combine the 20 and the 17. And then I'm going to subtract 3 from both sides, and I get 25. So 25 customers purchased only a hamburger. The last 2 things we're going to look at are difference of 2 sets and a Cartesian product. So the difference of two sets A and B is the set of elements that belong to set A but not to set B. And the symbol for it isn't anything like earth-shattering, it's just A minus B. Okay, so it's like you're subtracting two sets. So in this example, we've got our universal set, which takes the letters A through K, and then we've got set A, set B, and set C. So the first thing I want to find is A minus C. So if I'm looking at set A minus C, we want the set of elements that belong to set A, but not to set C. Okay, so what elements belong to set A that don't belong to set C? So if I look at set A, right, I've got a B and a B. So that means I can't use B when I'm subtracting. I've got an E and an E, and a G and a G. So that means if I was to subtract A minus C, I would have left in my set only the letters D, F, and H. So basically you're subtracting out the intersection. In the next example, I'm trying to find A complement minus B. So I'm going to look at A complement. Okay, so what's A complement? A complement is anything that's not in A, that's in the universal set, right? So in set A, I've got a B, so I can't use that, a D, an E, an F, a G, and an H. So A complement would just be A, C, I, J, and K. And then B is A, B, D, H, and I. So now I'm going to take away the intersections. So I can't use A, I can't use I, but I can use these other letters. So I want the elements that are in set A prime or A complement that are not in B. So here I'm just going to use C, J, and K. And the last thing we're going to talk about are Cartesian products. So Cartesian products of sets A and B is just the set of all possible ordered pairs of the form A comma B. So it's an ordered pair where A is an element of set A and B is an element of set B. And the symbol, it's just like for the difference of two sets, A minus B, a product means to multiply. So we're just multiplying A times B. And we read that as A cross B. To determine the ordered pairs in a Cartesian product, we're going to take out the first element of set A and form an ordered pair with each element of set B. Then we take the next element of set A and form an ordered pair with each of the elements of set B. And you keep doing that until you don't have any more ordered pairs to create. So it's pretty easy. So for this first example here, let's say set A is orange, banana, and apple, and set B is 1 and 2. So what I'm going to do is I'm going to find A cross B, I'm going to first take the first element of set A, orange, and I'm going to form an ordered pair with each element in set B. So the first element is 1. And then I'm going to go back to orange, and I'm going to match it up with the next element in B, which would be 2. Now that I'm done with orange, I'm going to go to the next element, which is banana, and I'm going to pair that up with a 1, and then it's going to be banana and 2, and then I've got apple, 1, and apple, 2. And then I'm finished any possible ordered pairs using all of the elements. I'll let you guys pause and try to find B cross A. You're going to do the same thing, except you're going to take the elements of B and match it up with all the elements of A. You're going to start with the first element of B and match it with each element of A, and then go to the second element of B and match it with each element of A. So to find B cross A, it should be this. And that concludes the notes for section 2.3. If you have any questions, please ask. Please let me know. Email me or contact me. You can also go to the learning support services at school, either face-to-face or virtually. I hope you all enjoy the rest of your day or night. And again, let me know if you have any questions. Thanks.